Hello everyone, this is Redzone 8A, and we are going to do this hopefully quickly and just reviewing what we have learned during the whole year. Make sure that you have a calculator like this one on the screen right next to you, so you could use this like to substitute basically and just get your answers pretty quick. So remember, when we're determining the y value in each equation by substituting the x values in that they give you, it's really pretty easy. So it's just basically you're going to use that equation and you're going to substitute that x in as 1, and that's just basically it. So you're substituting that in, and now that is your work that you are going to show on your homework, just like that. All right, you substitute in, and you take your calculator and you're going to put that is negative 3 times 1, and that's in parentheses, plus the 10. And you get 7, so you put 7 down as your answer. And that's all you have to do. You could press pause now, and we'll come back with all of the answers when you are ready. All right, so go ahead and press pause and do all of those problems now. So you could see all of the answers there. For the second one, for B, I put negative 3 times 5. So this positive 5 right here is what I'm looking at, and that's the thing that I have to, that's the number that they wanted me to substitute in for the x, and plus 10, and that equals negative 5, using the calculator all of the time. So it's y equals negative 3, and instead of the x, you get a negative 2. All right, they give you a negative 2. Negative 3 times negative 2 is positive 6. Positive 6 plus 10 is 16. Then for the final one, D, x equals negative 6. So instead of x, I substituted that negative 6 in. It's negative 3 times negative 6 plus 10. Negative times a negative is a positive 18 plus 10 equals 28. That's where that's coming from. Just remember, use your calculator. I'll just do 1 with you. Negative 3 times a negative 6 plus 10. And that is 28. All right, and that's basically it. So to go on to number 2. Number 2 says determine the y value in each equation by substituting the x values. All right, so you don't have to solve for y here, but I think you really should, because if you don't solve for y, then every time you go ahead and substitute, you would have to solve for y. So I'm going to put that down, and let's see if we remember how to solve for y. 4x plus 2y equals 10. You need this y alone. So what would you do to go ahead and solve for the y? You have to get this 4x over to the other side of the equal sign, and the first thing you do is the opposite of positive 4 is negative 4. So I'm going to bring that over to the other side. That will leave the 2x alone on this side over here, on the left side of the equation. So this cancels out. Then you have 2y equals negative 4x, and I put the negative 4x first because I like to see it in y equals mx plus b format, plus 10. Once I get up to this point right here, I have one more step, and then y is alone. This positive 2y needs to be split up. Right now it's attached by multiplication, and you always use inverse operations to kind of break up multiplication, and the inverse operation to multiplication is division. So we cancel out the 2 when we divide by 2 on both sides. You get y equals -4 divided by 2 is a -2. You bring the x down with it. All right. And then 10 divided by 2 is 5. So you have y equals -2x plus 5, and now you can use this to substitute every single one of these in, these values in for E, F, G, and H. So what I'm going to do is I'll do one with you. It's y equals, now we're going to use this one that we worked on, -2, and instead of x, we're going to put 1 in for that one and plus 5. So we have that right there, and that is your work. That's what you're going to show. I'm going to make that a little bit smaller so I could squeeze it in there. Remember, always using your calculator. You have negative button is down there, -2, and then in parentheses, you're going to put that 1 and then plus 5 all at once, and now you could get your answer. Press enter, and you get 3. And that's what goes here. Try the rest of them on your own just like that. Show your substitution, use your calculator, and get all of the answers. We'll come back to review them. Press pause now. All right, so there we go. I substituted in. The F, I substituted 5 in for x. I have y equals -2 times 5 plus 5, and I got -5. I substituted the -2 in for the x. -2 times -2 is +4. +4 plus 5 is 9 for G. And then H, I substituted this -6 in for x. Negative times negative is positive. That's 12 plus 5 equals 17. Again, use your calculator every step of the way, just showing what you are substituting in for your work, and you'll be good enough. So in this problem, we have 2 equations that we have to graph, all right? And I just want to review and take you step by step on how to graph, because we haven't graphed in a long time. Whenever an equation is in y equals mx plus b format, we say that that is standard form for any linear equation. And that is the form, that's the equation of any line. The m stands for the slope, and the b stands for the y-intercept. The y-intercept is very, very important. Both things are very, very important, because you need to know the y-intercept tells you where to start. That's the first point that you're going to put on your graph, coordinate grid. The slope tells you the incline or decline of the line. So from the y-intercept, the first point, you're going to either go up, down, left, or right, depending on the slope. So the first thing that I do all the time is to put the m down for the slope and the b down for the y-intercept for the first equation. The 2 right now is the slope. So I'm going to put that in rise over run, always rise over run format. The numerator and the denominator, the rise is the 2. It's positive, so it goes up. And the 1 is the denominator, and that is positive, so you go right. The y-intercept is the other number, so it is a -3. So coming down on with this question, we're going to start with a -3, which is right here. -3, you're going to go up 2 and run 1. Up 2, run 1. Up 2 and run 1. Up 2 and run 1. Up 2 again and run 1. Up 2 and run 1. And down 2 and left 1. Remember, all the points that you have that you're creating, should be in a very straight line. If there's one that is not in that straight line, that means that you made a mistake somewhere. All right, so then you take your y equals 2x minus 3, you go ahead and label your line. So for the second line, you have y equals negative 3x plus 7. So again, I am going to put down the m as negative 3, and I'm going to put that in rise over run format, just like I just said. And then instead of a rise of a positive 3, it's a rise of negative 3. That goes down 3, and positive 1 goes to the right. The b, which is the y-intercept, is 7. So, do this in a different color. I start at 7, and I'm going to go down 3, 1, 2, 3, and to the right 1. All right. Down 3, 1, 2, 3, to the right 1. Down 3, 1, 2, 3, to the right 1. And there is my solution. I'm having problems with the writing. All right. And then down 3, keep on going. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. And I can't go any further. I could go a little bit further up here. 1, 2, 3, to the left 1. So I am going to connect those points in a straight line. And you notice that it is a straight line because I did not make a mistake with my counting. And I'm going to make sure that arrows are on each side, not an arrow like that, because that arrow looks horrible. An arrow that looks pretty bad. All right, so I'm going to move this over, so this is definitely for this line, and then I am going to go ahead and make sure that this line has its own label. All right. So just remember also, when you're graphing more than one line on a graph, that's when you need the labels. If you're graphing one line, they usually don't ask for you to label the line, but it's very, very important to label lines times when you're graphing a system, because you're always graphing more than one line on one graph, one coordinate grid. So let's just go ahead and pinpoint the solution. The solution to any system is where those two lines intersect. And they intersect at 2 to the right and 1 up. Do you see this right here? That is the solution. So the solution is 2, 1. And that's it. That's how you do it. All right. So number 4. Number 4 is a little bit more difficult, and I'll just go through what you have to do. You definitely, these are not in y equals mx plus b format. Remember, they always have to be y equals mx plus b, and that is the equation of any line. If it's not in that format, that means you have to solve for y. All right, especially, obviously to graph, you need the y-intercept, you need the slope. No way to do it if you do not solve for y. So the first thing I am going to do is start messing with the first equation. So I have 2x plus y equals 6. How do I solve that for y? What do I have to move to the other side of the equal sign to get the y alone? And again, get into format y equals mx plus b. See this 2x? This 2x must be over onto the other side. So I am going to subtract that 2x because it's opposite of a positive 2x, which is a negative 2x. When I do go ahead and subtract, guess what I have by myself? This is kind of like a one-step equation on how to solve for y. So this is y equals, and I'm going to put that negative 2x first because I want it in that y equals mx plus b format right off the bat. I'm not going to put the 6 first. It's okay if you put the 6 first, but you know, I just don't like to do it that way. M equals negative 2, and I'm going to put that always, when I am graphing, I am going to put that in rise over run format. And right away, I know that the negative 2 is a rise that goes down, which doesn't make any sense, but anyway, it's not a rise, it's a decrease of 2, and to the right 1 because it's a positive 1. B equals, and b is always the other number, b equals 6. So I'm going to go to 6, and I'm going to go down 2. I'm going to follow my arrows down 2 to the right 1, 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 and I'm going to keep on going down 2 to the right 1, and until I run out of space. Then I go up 2 to the left 1, up 2 to the left 1, okay, so I graphed my line here and we are good to go. I am going to put y equals negative 2x plus 6. And that is my line right there. All right, I could even put it this way if I wanted to, doesn't matter. Alright, so now we have 4x plus 2y equals 0, which is a little bit more difficult. A little bit more difficult. So I have 4x plus 2y equals 0. So what do I do to solve for y? This 4x needs to move over. So it's a positive 4x. You have to get that over onto the right-hand side of the equal sign, away from the side where the y is. And now you would go ahead and cancel out the 4x and the 4x and the negative 4x. That cancels. You'd bring down the 2y and you'd bring down the equal sign, and the only thing left on the right side is what you moved there is the negative 4x. So the last step is to divide by 2. And the reason why you're dividing by 2 is because you need to separate the 2 from the y. So now you have y equals a negative 2x. Y equals negative 2x. So you have y equals negative 2x, and now you have your slope is negative 2 over 1. And that's down 2 and to the right 1. And the y-intercept, when there is no y-intercept that is there, the y-intercept is 0. So we're going to start at 0, and we're going to go down 2 and right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. Up 2, left 1. Keeping with the pattern of the rate and the slope of this line. Up 2, left 1. Up 2, left 1. Once you have that down, you could go ahead and connect those points. Connecting those points, you realize that these lines are never going to meet because they are parallel. Does anybody remember y, or can anybody tell that they were parallel right off the bat? They were parallel because it has a -2 as the slope, and this -2 right here of the slope of the first equation is the same. So the slopes are the same. When the slopes are the same, then you have parallel lines and you have no solution. So just remember, you have the same slope. That means these lines will never meet. So you have no solution. There is no solution that you could put down for this because there is no intersecting point. If there is no intersecting point, guess what? There is no solution. You notice that it's y equals -2x and y equals -2x plus 6. And that is no solution. So determine the solution to the system of equations of y equals 4x plus 6.5 and y equals 5 over 2x minus 3.5. So what we're going to do right now is just basically, if they, remember and bring up the phrase that we used in class so many times. When they're both equal to y, they are both equal to each other. So that means please go ahead, set these equal to each other, solve for y, solve for x, and then substitute back in to one of the equations to get the y. We're going to press pause and we're going to try that problem out right now. Hopefully you can get that correct. Press pause now. So taking a look at this, and I have 4x plus 6.5 equals 2.5x, and I changed the 5 over 2 to a 2.5 because I think it's easier to work with as a decimal, minus 3.5. So what you do to solve, remember, you always get the smaller, try to get the smaller x over to the larger x. And in this case, I subtracted the 2.5x on both sides. 4x minus 2.5x equals 1.5x, and I bring down the plus 6.5 equals, and I bring down this negative 3.5. When I subtracted a 6.5 from each side, I used my calculator. So I have negative 3.5. I have a negative 3.5, so I'm just looking at negative 30. Negative 3.5 minus 6.5. And that's how you would put that in. You press enter and it'll give you a negative 10, and that's what I have here. Right, so now I have 1.5x equals negative 10. And I divide by the 1.5. All you have to do is press divide, and then divide by 1.5. You'll have your negative 10 divided by 1.5, and I have negative 6.66666, and I rounded it to negative 6.7. And in this case, that's what my x is. X equals negative 6.7. I picked the first equation to substitute that x into. So what I'm doing is that I am substituting my x, negative 6.7, in for the x in the first equation, and I put that in my calculator to get negative 20.3. Hopefully you did get that and everything worked out like that. All right, and that's how you would do it. Remember, when they're both equal to y, they are both equal to each other, and that's how you do that problem. All right. All right, so number 6, you have y equals 3 times, in parentheses, 0.5x minus 4. Remember, go ahead, do distributive property first. And they're both equal to y again, so you're doing distributive property, but you have to do distributive property, and then you'll get the y equals, and you'll have this y equals, change that 3 over 2 to 1.5x, set them equal to each other, and then solve for the x. Once you're finished, that means you could go ahead and then substitute your x for the y for the x, and then solve for y in the equations, in one of the equations, and get the solution. Go ahead, try this problem right now. You could press pause now. So distributing that 3 to a 0.5, right? You do 3 times 0.5 and you get 1.5, and you get 3 times a -4, which is a -12. Then you bring this down to 1.5x minus 1.2, and you go ahead and subtract the 1.5 from both sides. Basically what I'm looking for is a smaller x in this number, and guess what? I don't have it. I have 1.5x minus 12 equals 1.5x minus 1.2, which could never be, right? So I just go ahead and subtract the x's, and they both cancel, and I bring down this -12, and I'm bringing down this -1.2. -12 does not equal -1.2. So the numbers are not the same on either side, so there's no solution. We don't have a solution for this question. Basically because at the beginning you have y equals 1.5x minus 12 and y equals 1.5x minus 1.2. It's impossible for those to be the same with the same value, to be equal with the same value of x. So there is no solution, and you prove it by showing this work, and that's it. All right. So number 7 is something that we've gone over a number of times, but we do have to review and make sure that we actually know this question. All right, so you have 2x plus 5y equals a -8, and then we also have 3x minus 5y equals -13. So remember, there's no y equals and y equals, so you can't set these equal to each other. What you do is look for my favorite method, which is substitution. I'm sorry, substitution is not my favorite method. Elimination is my favorite method, and we are going to use it right here because all of these are set up as set up for elimination. This one is set up for elimination. So which variable eliminates, the x's or the y's right now? Right? If you're taking a look at the x's, the 2x and the 3x, they do not cancel. But the positive 5y and a negative 5y, that cancels. So you could go ahead and cancel it right now. All right? They're gone. So you have 2x plus 3x, and that is 5x. So go along and please show all of this work. All right? You have a -8 plus 13. So I'm going to put that in the calculator because, again, I don't want to make a mistake on something like that. I'm going to start it over again, -8 plus 13. And I have a 5. So that's okay. So I have 5 right here, and it's a positive 5. To solve for x, I'm pretty sure everybody understands how to solve for x. You're dividing by 5, and you're dividing by 5. The 5's cancel, the x rolls down on its own, and 5 divided by 5 is 1. So x equals 1. You could put that in as your solution. But we need a y. So which equation looks easier to you to use? So I'm going to just use that first one. I don't know. It doesn't matter, really. And I'm just going to write that down. And instead of the x, the second time around, I am going to substitute that x as 1. And just like that, I am going to get 2 times 1, which is 2. And plus 5y equals -8. And remember, I have to solve for y. So now it becomes an easy question for becomes an easy question. All right, so this cancels, and you have 5y equals negative 10. And that's nice. Isn't that nice? Oh, yeah. Oh, yeah. Right, so you divide by 5, and you divide by 5 on both sides. And guess what? The y equals negative 2. Y equals negative 2. And remember, the way you, if you wanted to check this, you would actually take these two numbers and substitute in, and this 2 times 1 is 2 plus negative 10, which would be 5 times negative 2, which is this y. 2 plus negative 10 equals negative 8. You would have to check both equations, and they would have to be equal to what they say for it to be a correct solution. And in this case, we have a correct solution. All right, and that's basically how to do number 7. Going on to number 8, again, I always look to use elimination. And I noticed that x does not cancel with 3x, and negative 3y does not cancel with negative 5y. So I am in trouble. I'm not really in trouble. I'm just saying I'm in trouble. So I would have to look to multiply something by the either top or bottom equation, and I'm going to look at the equation on the top, and I'm going to put parentheses around that equation, and I am going to look to either make this x opposite of this positive 3x, or this negative 3 opposite of the 5y, negative 5y. So I'm focusing on the x's. What do I have to multiply this x by, or this whole thing by, to get this x to be opposite of 3x? And you just take a moment to think about that. What is the opposite of 3x? Positive 3x. If you're saying, all right, it's negative 3x, you're correct. It is negative 3x. So that's what I'm going to multiply by, because this is a positive 1. So it makes it a little bit easy, because it really not worried about the rest of the numbers here, or the y in that matter, for that matter. But you do have to distribute to them. But this is the bottom line. You have to get one of these variables to cancel out. And as long as you get one variable to cancel out, you can solve for the other. So I'm going to distribute this negative 3 here to this x, and this negative 3 to this negative 3y, and then the negative 3 finally to the 1. So you have negative 3x, negative 3 times x is negative 3x, negative 3 times negative 3y is a positive 9y, and a negative 3 times 1 is negative 3. And that is my new equation. Now I'm going to type down, or write down, the 3, I'll type it. So I'm going to put 3x minus 5y equals 13. You really don't have to write it down again, since it's right above where my red equation is. So we have this right here canceling out, because that's exactly how I wanted to get that to basically happen, because I need one of these variables to cancel. I have the x canceling now, and I'm going to bring down this 9y minus 5y as positive 4y, and a negative 3 plus 13 as a positive 10. To solve for y, I divide by 4 on both sides, and I am going to use my calculator to get the y equals. I'm going to use that calculator because I don't want to make a mistake. 10 divided by 4 is 2.5, and that's what y equals, that 2.5. Just remember, it is easy to make a mistake here, so I'm just going to go over negative 3 times a positive is negative, negative times negative is positive, negative times a positive is negative. All right, so I have 2.5 as the y. Just remember, don't put it in as the x, because then that will mess things up. I'm going to pick one of these equations to substitute in that y. So I'm going to pick the first equation, because it just looks a little bit easier to me. You could pick the second equation if you want. And I am going to substitute that 2.5 in right here. So when I write it down again, I am going to use parentheses, always using parentheses when I substitute. So I need the negative 3. I'm looking for my calculator. I'm going to put it over here for now. So I have negative 3 and in parentheses 2.5. Close parentheses. So it is negative 7.5. So I have x minus 7.5 equals 1. And then all I have to do to solve for the x is to add 7.5 to each side, which is rather easy. And then plus 7.5. And I get x equals 8.5. All right. And the solution is 8.5 comma 2.5, and you're finished with the problem. Just remember, elimination is definitely the best way to go. The only time you don't use elimination is when it's set up like ready to use substitution, like if it's y equals and y equals, or one of them is equal to y and the other one is not. You could always use substitution that way. So this solution right here, again, I used elimination to get the x's to cancel. I multiplied by a negative 3 to get those x's to cancel. Again, you could make this a little bit more difficult of a question, and you could get the y's to cancel. Do you know what number I would have to put here to make this? I'm sorry, yeah, it's not really an easy way to do this. So again, if you wanted to get the y's to cancel, you would multiply this by a negative 5 and this by a positive 3. If you multiply this by a negative 5, you would get a negative 15y, and this by a positive 3, negative 5, you would get a positive 15y, and this here by a negative positive 3 would make that a positive 15y, negative 15y. Woo. All right, so as long as you have negative 15y and a positive 15y, they would cancel. And I'm sure you're confused now. But, all right, let's go on to number 9. Looking at this, I see that I could either get the x's to cancel by multiplying the bottom by something, bottom equation by something, or you can get the y's to cancel by multiplying the bottom equation to something, or the top. You decide what you want to do to get whatever you want to cancel. There's no wrong answer. Go ahead, see if you can do it. Try it. We're going to press pause. I'm going to give you a little chance to do it. Press pause now. Okay, so you're dividing 4 right here. First off, I multiplied by negative 1. Let me go back up. The reason why I multiplied by negative 1 is because I wanted to change this to a negative 4y, and that would cancel out here. You can multiply by negative 5 and change this to a negative 5x, and it would be the same thing because the x's would cancel at that point, but you're going to get the same answer. Since I did negative 1 times x, I got negative x. Negative 1 times 4 is negative 4, and negative 1 times negative 5 is positive 5. Since I did that, I cancel out the y's. And then I have negative 1x, and I copy down this equation again right below it so that I could see exactly what's going on. I get 4x, negative 1x plus 5x is 4x, and then I get 5 plus 7 is 12. Divide by 4, you get x equals 3. Now I'm going to take the probably the top equation because everything is positive, and I'm going to substitute in for x my 3. Just like that. Then I'm going to have the 5 times 3 is 15. 4y equals 7. And I am going to grab my pen and subtract 15, solving for y, because I need to solve for y here. So I minus 15 on both sides. And this cancels. I have 4y equals, and it's 7 minus 15 is, just to make sure, 7 minus 15, negative 8. So that's good. Divide by 4. Divide by 4. Y is negative 2. Make sure you put that down. That is all the work that you have to show. X equals 3. And that is basically it. All right. A lot of different ways to do it. I picked one way. I like multiplying by smaller numbers. If you said negative 5, if you wanted to multiply by negative 5, you could have multiplied by negative 5. So here's number 10. Go ahead. This is the most difficult problem. If you could do this, you could do any type of problem. You'll be fine in high school with this type of work. Remember, the x's are the ones that you should really be going after to cancel. So you're going to multiply the bottom by some number. Pick that number. Try to solve it. Press pause now. Okay, so I did choose to have a negative 2 multiplied by a negative 2 because I knew that negative 2 times 3x would be a negative 6x, and negative 2 times 2y would be a 4y. But I'm really just concerned about the x, because multiplying by negative 2 would get the x to be, the coefficient, to be opposite of what I had as 6x. So I'd get that negative 6x, and now I'm just copying down that first equation again. Just like that. All right. Looking at it like this, now I could see that, hey, this cancels. Negative 4y plus 3y is negative 1y, and I'm putting the negative 1 in front like I don't normally do that because I know there's another step coming up, and I want to make sure that I know that I have to do that step. So it's negative y equals negative 6, because negative 20 plus 14 is negative 6. Divide by negative 1 on both sides. Divide by negative 1 on both sides, and you get y equals 6. So y equals 6 is your answer for y, your value. All right, so part of the solution. But you need x. So I am going to go ahead and pick the bottom equation. I don't know why. It doesn't matter really. You have 2y equals 10. So I am going to put that 6 in. I'm going to substitute that 6 in for the y and use parentheses when you do it. Right? Moving that up just a little bit, give me some space. 3x plus 12, because 2 times 6 is plus 12 equals 10. Right? So we're going to do a little bit of work here, solving for x, which is pretty easy. You minus 12 on both sides, you minus 12 on both sides, and then you get 3x equals negative 2. I'm going to just divide by 3, and instead of leaving this as a repeating decimal, I'm just going to leave it as x equals negative 2 over 3. And that'll be it. That's your solution. Just remember trying to look for elimination. If it's set up, it's an easier problem. If it's not set up, you do have to multiply one of the equations to get either the x or the y to cancel out. And when you do, you could solve for the other one that is still left. And that's basically it. See you next time. Bye.